Latitudinal temperature differences of Mars heat the surface and atmosphere unevenly, generating a huge convection loop in the atmosphere called the Hadley cell. Hadley cell circulation develops as warm air expands and rises from the warm equatorial region, flowing at high levels in the atmosphere toward cooler polar regions. In the polar regions, the air cools and sinks to the surface. From the poles, it flows along the surface back to warmer regions in the lower latitudes to be heated again. On Mars, the ascending branch of the cell typically causes westward jets over the equator, and the descending branch of the cell generally gives rise to a strong eastward jet of winds or polar vortex. The characteristics of these cells show marked seasonal differences. Because of the high orbital eccentricity of Mars and the resulting large seasonal differences in heating, its Hadley circulation is stronger and wider during the northern winter than during the southern winter. Between early spring and fall, when the sun is over the mid-latitudes of Mars, is when Hadley cells develop in each hemisphere. Wind speeds of the polar vortex range from 90 to 100 meters per second, 200 to 225 miles per hour during these times. In Martian winter and summer, when the sun stays above the horizon at high latitudes, a single huge Hadley cell develops in the warm hemisphere that extends across the equator. Typically, in the winter hemisphere, the marked differences in temperature between the descending branch of the Hadley cell and the polar night causes strong eastward polar vortex winds to develop. Winds in this vortex can be nearly 160 meters per second, 360 miles per hour. As in Earth's atmosphere, this simple north-south circulation is broken into smaller cells by Coriolis forces. These sideways inertial forces are caused by the rotation of the planet. The equator of Mars is moving eastward at a much higher speed than the area around the poles. Therefore, the air masses moving away from the slow-moving poles appear to lag behind and shift westward, while poleward-moving air pulls ahead to the east. These deflections produce a spiral motion in the atmosphere that influences zonal, that is, trade winds on Earth, and sets up turbulence and cellular patterns associated with cyclonic storms. And that's winds and circulation patterns of Mars. Have a great day.